Hi all. First of all, I want to introduce my talk saying that you might see code that will be harmed during it. So if you are like weak at heart or something and you do care about code, you might to take a break at some point. But yeah, let's just start. So this is zombie code, or how to survive a JavaScript zombie code apocalypse. I am Marco Cedaro. My name is ChadMax, basically everywhere online, so you can find me. And I'm part of the Shazam web team. The four of us are here around, spread. And you can see the whole team coding and dealing with legacy code here just outside the main door of the conference last year. So let's just go through it. So zombies. Zombies are about brain, right? Everyone knows that. But what is zombie code, right? What do I mean with zombie code? So zombie code is not dead code, first of all. It's code that actually is out there, is running, is in execution in your user's browser, is just code you don't really want to deal with. No one touches it in ages. It's just living there. Someone calls it legacy code, someone calls it crappy code, or like the code that guy that left wrote 6 months ago. Anyway, it's the code that you know that is there, but is like, no. And it's the one that is a nightmare to add feature to debug and stuff. So the thing is, it might seem harmless because it's there. In the end, no one cares about it. It's running. Why make it a big fuss about it? The thing is, when it grows and you have a swarm of that code coming at you, it's deadly a problem. And that's because it will eventually eat your brain. And that will happen specifically, first of all, during estimation, because you wouldn't know how much time it would take to add a feature or something to your code base. And during debugging, I wish you luck debugging code that has been written without testing or anything, or during feature development itself. So it is, in the end, it is dumb code that makes you dumber as well. But the good news is that it might be not too late for you. You just need a few hints on how to identify it. How do we know what is zombie code and what is not? The good thing, again, there is good news all around, is that zombies smell. And your code might be smelly too. There are several things that you can feel about your code. And I have 3 tips for you straight away, just that could help you identify it. The first one is that code should be appealing. When you read the code, you shouldn't see any function this long, for example. This is a method from one random jQuery plugin. I don't want to backslash the people that helped building it. It's not like pointing the finger. It's just saying, it's long. It's long. You don't want a function that long. And you don't want that many ifs in a method as well, like 14 ifs, really. There might be some problems, right? You might feel that there is something that is not quite right. And as well, comments. There is comments all around. You might think, and you might be right about that, it's just the comments are not a bad thing, right? Well, again, you might be right, but code should talk to you, in my opinion. And when the code is something like that seems written for machines, then there is something that is weird, right? Have you ever seen code like that, written by people to be like that, to optimize, to be? This was a joke, like a few years ago, making a tweet with a JavaScript function that was actually working. This is a pub sub implementation in 140 bytes. The original function was this one. Is much more readable. You actually understand what's going on. I don't want you to read through right now, but if you did, you would understand everything that is going on. And again, good luck debugging something like that. Well, this might be a decent experience. So my point is, don't use comments to write bad code. Don't use them as an excuse to write bad code. Comments has their place in software development, and their place might be to explain unavoidable acts when you have to, because some browser doesn't support something and you have to trick them, or when you have to generate documentation or to-dos, or again, whatever. There is good cases for comments. Just don't use them as an excuse. That's it. The third tip is about the fact that code should have personal boundaries. And yeah, what is a personal boundary for code? Yes, sure. Well, it could be the single responsibility principle. So you have one script, it does one thing, and it does it well, like an axe. An axe does one thing, it cuts, right? It's a great tool using the single responsibility principle in the right way. Another way you can see the concept of boundaries could be not polluting the global namespace. That's another good thing that your library should do. And no coupling. Your script shouldn't really have hard dependencies on other script. You can either inject dependencies or, no, well, just inject dependencies. Anyway, this is another smell that you can find in your code when you cannot like abstract something from something else. The point is, while working, you will get to develop a code sense at some point. Robert Martin says, writing clean code requires the disciplined uses of a myriad little techniques applied through a painstakingly acquired sense of cleanliness. This is something at some point each of us went through and saw his old code and said, was I drunk? Right? It does happen to anyone, that's right. So there are a lot of small things that we can see in our code that are like a sign of some refactoring that might be needed. So if you have log methods, again, deep level of indentation, I'm not talking about cyclomatronic complexity or whatever, because it's not rocket science, it's JavaScript. So it's like if you have many tabs before your code, maybe there is something that you should think about refactoring. If it is hard to tell what it does, you read your code, you don't get it. That's weird. If it's not portable, you cannot abstract it. Again, you cannot take it out and use in another context without having to change it badly. Or if you have any style or templating are coded, or logic block duplication. If you have a lot of code and, copy and paste around, that's another sign that there is something really bad going on. Or again, callback hell. Everyone was there. Now, did you get pretty much what I do mean for zombie code? OK. So now we got it. This is zombie code. What do we do now? We play cool. Thank you. So the first step is quarantine the code. Most teams are trying to stop further spread only through quarantines. It's a good short-term solution, but it won't prevent long-term population loss. Quarantine works. It's not a solution, but is the first step. Are you comfortable with the concept of the broken window? Have you ever heard about it? So in social science, there was this scientist, I don't remember his name to be honest, he theorized the fact that if something is left not fixed, if something is broken and is left not fixed, people will just make it degenerate and vandalize it more. In order to prove that, he took two cars and they put one in Bronx and one in Palo Alto. And obviously, Bronx is like a more degraded area than Palo Alto. Palo Alto is fancy and stuff. The car in Bronx was vandalized like in a couple of hours or something like that. And yeah, broken windows, part of the car taken away, but not from like not thieves and stuff. It was normal people, like parents with children going there and actually doing things to the car. It was weird. In Palo Alto, on the other hand, the car stayed there for like weeks without anyone touching it. At this moment, the scientists decided to break a window of the car in Palo Alto. And in a couple of days, the car was vandalized as well. And it was the people from Palo Alto, again, like normal, white male, fancy and rich, living in Palo Alto, doing the same thing that was in Bronx. And that's because, again, we have this assumption that if something is trashed, it can be trashed. Right? If there is an area in which there is litter, someone else goes by and puts something else, at some point everyone will put there is trash, right? Because that's supposed to be the area in which there is trash. And that's exactly how our brain is wired to think, right? So, sorry, wrong direction. So there was a beautiful article about from Jeff Atwood, Coding Horror in 2005. And he's speaking exactly about that. Don't leave broken windows, bad design, wrong decision, or poor code unrepaired. Fix each one as soon as it's discovered. I'm sorry, it's quite long. I put all of it because it's quite good. Programming is insanely detail-oriented, and perhaps this is why. If you're not on the top of the details, the perception is that things are out of control, and it's only a matter of time before your project spins out of control. Maybe we should be sweet in the small stuff. And that's the key, in my opinion. We should have this sense of checking our code and feel that our code is wrong and fix it straight away, not leaving, yeah, I'll do that next month, whatever. It's not going to work. It will just spin out of control. So again, let's start isolated zombies as soon as you see them. And there are a few things you can actually do proactively to isolate them. And one of them is define style guides within your team. You can actually decide how the code should be so that everyone writes the code in the same way. Most of you is doing that already, isn't it? So you don't want anything like that, that is like completely random, like with new lines and stuff. I know that, what is, Gunnar likes new lines, but yeah. So it's like you don't want the code to be randomly styled. And you may want to enforce that during your CI process. You may want to lint your code and enforce some of these rules. And that's because you can actually make the machine take decision for you. You don't have to spend your time thinking about you write your code. You have immediate feedback on what's wrong and that you can fix it straight away. Another thing you can do, and you should do, is start testing the code that you're started writing now so that the zombie code is isolated and cannot spread this disease to the rest of the code. So the code that you write now on should be tested. How? Unit or functional? You know the difference about unit testing and functional testing, right? The unit testing is the single unit of logic that you can test, the smaller one. The functional testing is the full thing as a feature. Like, again, the small block of Lego and the house. Like, the small block of Lego needs to fit with the others, while the house has a shape, has a roof, the roof is red, etc., etc., etc. That's the thing. You actually have to do both. They're two different things. You need both for different reasons. One is to guarantee your business people in the company that you are delivering what they ask for. And the other one is for you to be able to refactor the code or understand in a few months what's going on. Because in the end, the test is also a live documentation of your work, right? And automate it. Make it something that gets executed at every check-in you do, and make it part of the process. This is something that needs to be done as part of your working workflow. And when I say part of the process, I don't mean just technically. I mean also as working process with people. So the testing should be estimated. It's not like I'll deliver this feature in a day and a half. It's a day and a half plus the testing. I do need time to write unit tests because it takes time. It's not like for free, but it will guarantee for you that in the future you get to change feature to add-ons and stuff in way less time than if you didn't. Do code review. No, it's the wrong image. I mean, that's not the concept. It's your code that needs to be code reviewed, not other people's code. So it's like, you are that guy, not the hand, OK? And again, involve people in the process. Because the thing is, we are not Highland. Don't fear the living. The living is people that will help you. You're probably working in a team, right? And this example of the team is a team of probably a quite big company. We have DevOps, QA, and product owners and stuff. But if you work with clients, you might have certain people that takes care of the different areas anyway, even those are not the names. In my experience of being working, Shazam is decently big. We all have all these roles. And when we've been through the refactoring of our system that was quite bad back then, we involved all the people. Like the QA person is really crucial in the process of isolating the bad code because they need to provide you, to help you, looking at the quality of the end result and guarantee that the features that you're changing or refactoring are still working in the same way they were supposed to be. Because that code that was working before needs to be working feature-wise in the same exact way. You need just better code behind it. It's not like it has to stop or change the feature. The DevOps as well, they're crucial to be part of the continuous integration process. They are the tough guy. Have you ever had to deal with DevOps? No? Huh? So they are the ones that wakes up at night when the site goes down. And it's painful, and you should feel them. They need your help. Hug them. Go back to your office and hug your DevOps, because he's the one that wakes up when you fuck up with the code. So this guy is the one, again, that helps you setting up the automated process, helps you having a short iteration feedback from your CI environment. Hug him, really. And then the product owner. The product owner doesn't really care about the code. is the one that will help you stay focused on features. Again, the code is you delivering features. The feature is the business value. It's not the code itself. Keep that in mind when you code. And there might be other people in the company anyway, juniors and other people in other teams, which I refer to as external lobbyists. So the juniors, well, the juniors sometimes are annoying. Come on, let's say that. But again, they are the first one that dies in the movie. So again, you should be stay close to them, help them learn, and get them to give feedback, because it's very important for you not to overthink things and to keep them simple anyway, for your own sake, not just for theirs. It's a value for the company if your code and system is simple. As for the third party, the people that is in another team or your client formal or whatever, they will slow you down. It's a big deal. Refer them to the right person. Don't deal with them. Just don't reply the email. Forward them to the product owner. He will deal with them. There is a business person to do that. It's not you. Unless you are a freelance. Sucks to be you. Kill them all. After you quarantine your code, and you created new code base, which is clean, healthy, tested, and etc., you need to go back and get rid of the zombie code. Nothing is impossible to kill, so don't be afraid about that. But a goal without a plan is just a wish, and therefore, you should design for your goal. This sentence is amazing. Take your time to read it. Without requirements or design, programming is the art of adding bugs to an empty text file. Please, an applause for this guy. It was a warm anthem for Louis Shirley. Design for your goal. And by design, obviously, I mean architectural design. Think about what you have to do. As for us, we decided to go for something that I will introduce in a minute or so. It's called a Kaze. We have this little demo on my GitHub. So we started thinking about what kind of architecture we wanted. And we went for a modular architecture. Is there anyone knowing this slide? Have you ever seen this slide before? Raise your hands. One. Rocco. Yeah, the Shazam team. Yeah, OK. So this is Nicolas Zaka's scalable JavaScript application architecture back when he was still in the Yahoo homepage team lead. And this is quite simple overall. The idea is perfect and simple. So you have modules that are the single small unit of business logic on the page or the website. And they do one thing, they don't know about each other, and they are completely unaware of the rest of the application structure. A module looks like pretty much something like this. So you register on the core a module that has an init and destroy function, which are the ones that deal with the life cycle of the module itself. And there is these things that get injected in the constructor, which is a sandbox, that is the core API of your application. So you define what is the interface that the modules rely on, and that's the only thing they know about the architecture. The sandbox is the thing that you have to think thoroughly the more, because it's, again, the only thing that is available across every module. So you might have, depending on your application, something like sandbox get user, or whatever, depending on your application idea, structure, and whatever. And at the bottom of it, there is the application core, which takes care basically only about the life cycle of the modules. Decide when they start, when they die, and how to configure them. So you might have methods like those. So you register modules, you configure them, the configuration is obviously injected in the init function, start, and stop. That's pretty much the whole interface you need on the core. And then, yeah, obviously, of course, you might have jQuery or whatever you want at the bottom of it to be a base library to deal with. So yeah, this is pretty much the architecture we went for. This was pretty elastic for us. It was the thing we were looking for. And we decided, and this is actually part of the architecture itself, to have an event-driven pattern to have the modules communicate each other. So That's good, because instead of having something like this, if you have an error, for example, instead of calling a layer, which is reasonable if you think about it, a solution like this one would be much better for several reasons. First of all, because, well, with a subscribe, you subscribe to the channel error with a function, and when the error channel gets invoked, with a publish, the message gets injected. That's as simple as that, really. This thing has a lot of advantages. First of all, it's semantic, so you know what's happening. You just push through a channel that has a name, and you decide the name. So it's like an API, but it's not an R dependency anyway, because it's flexible. You can change whatever in the same place, and you can even get rid of it, and your library will still work, because stuff that gets published to a channel without anything attached to that channel is not breaking your app anyway, right? So in different contexts, you might have different reaction to the error itself. So in dev, you might want the error to log something to the console, while in production, you might want, again, to warn the user about error happening. So it's really flexible for you to do whatever you need. Is this over-engineering? This is a question we asked ourselves at the beginning. Again, Zakas, when he explained this thing, he said the key is to acknowledge from the start that you have no idea on how this will grow. When you accept that, when you accept that you don't know anything, you begin to design the system defensively. This is pretty much what this architecture is about. And on the top of it, we decided to go for AMD. You have to remember it was roughly 2 years ago, so it kind of made sense, the choice back then. You know about AMD, right? It's kind of established. You have a definition, a defined function that has an API. This is quite simple. You define with an ID, dependencies, and the factory, and you inject stuff through it. So you get a modules that can look like that. This module has this name because the path is the actual name of the module itself, and returns this object. And then I can call that as a dependency of another module. It gets injected, and I can use straight away the properties from the original module. And this is the name of the new one, and so on. It returns a constructor that takes an ID and returns its instance with a get product URL thingy. And then you get the main that require.js loads, in which you can inject your stuff as well. The cool thing about this is that the dependency management is quite simple, it's quite readable, and it's nice to have automatically on dev the list of HTTP requests of your libraries, and to have the bundle in production produced during continuous integration. This was the choice we made, and we are kind of sticking to it right now. And again, pulling all together, we built our own module that is this Akaze thing that provides this API. So it's AMD, and you get a constructor with the sandbox injected, and then the init and destroy function in our modules, and the publish subscribe approach. And Akaze itself as the start, it's the core, start, configuration. And in our case, we wanted some module to start when an event was running through the application core. So that's Akaze pretty much. Of course, 2 years later, some of the choices that we made are kind of updated, right? So the main drawback of require.js is that the configuration is awful. If you've been doing require.js, you know that not every library out there is supporting AMD straight away, so you have to shim stuff, you have to define path if you're using weird folder structures that is not exactly what they want you to use. So you'll end up with a huge configuration file that it might be hard to maintain at some point. And personally, I do still prefer require.js API rather than common.js to define things, because I like the list of dependencies at the top of the file. But as many of the speakers already said, ES6 is providing a way better API for that, and hopefully that will be at some point available straight away. I know there is still some point with some libraries that are not still compliant to this thing, but I'm not really updated on this. We didn't explore that yet. The whole point, anyway, is that there isn't such thing as a silver bullet. This thing that I showed you is good for us, was good for us when we made the choice, and right now we are considering it, but still, it's not bad. What I'm talking about when I say design for your goal is that you need to know your goal up front and take your own design decisions. Think about it. Don't just leave it as it is because you choose one framework or the other, or because that was the thing when 2 years ago you joined the company and that was it, and you're still doing the same thing. Think about it, because you could find a better solution for that. Is there an happy ending? It depends. If you want an happy ending, that depends, of course, on where you stop your story. So the thing is, you can actually run and hide, but you're going to write shitty code anyway. Sorry, zombie code anyway. There's no way out of it. You will have an hard deadline tomorrow. You will have to code overnight. You will have to fix a bug. You will have to do something that is going to make your code worse. Deal with it. It's going to happen. The thing you need to know, though, is that you don't need to improvise. You have to learn how to deal with it, right? Have a thought about it up front. Don't get last minute to think about it. And at some point, you'll master it. So you will still write shitty code, but you will have some ideas on how to fix it afterward, right? And just in case, please remember to aim for the head, right? And that was me. Thank you.